Hello everyone, Sebastian here. Welcome to the second part of Panzer Postmortem devlog series. In my previous video I talked about the reasons why I selected MicroStudio as my game engine of choice for this project, and this time I will finally get into it and discuss how the project is structured. I will talk about architecture, DD and OO, as well as how basic grammar helps to make a game dev easier. So let's get started. MicroStudio starts the developer off with nothing but an empty game loop. While this gives user a lot of freedom, it can also be quite intimidating. How to go from those three methods to a working game is not obvious at all, and it becomes even more complicated still when things like menus and the load screens are added to the mix. But I'll get to that. First, let's put something more visually stimulating on the screen, like a tank. Tanks are cool and make explaining things a lot easier. Now, Panzer has a lot of tanks on the screen. They drive around and shoot and explode and do stuff, but right now the most important thing is that they are visible, they have been drawn, and that's exactly the name of one of the methods that MicroStudio provides with an empty project. Those names matter. They are hints that tell what should be done in those methods. Draw means that this is the place where all drawing should happen. When I put a draw sprite call inside the draw, I will get my tank drawn on the screen. I can put a lot of tanks on the screen. It's that easy. And now move. Move? Move please? No? Okay. The second hint that an empty project gives is that stuff will need updating. Like updating tank position on the screen for it to look like it's moving, for example. But the actual drawing needs to stay in draw, so those two variables can be used to pass info or data between update and draw. MicroStudio calls update 60 times per second on its own, so by increasing the x value by 1 on each update I'll get my first bug. If you wondered what a tank centipede looks like, there it is. MicroStudio also calls draw multiple times per second, so I was just drawing over and over on the same image. All it takes is to add a clear screen. Remember kids? Always draw on clear screen. I added wraparound when the tank reaches the edge and a bit of more speed and moving tank. This is it. This is how a game loop can be utilized to make a game or even any other kind of application. Variables that are updated 60 times a second, and then content on the screen is redrawn based on the current values of those variables. Obviously there is quite a lot of time left on the video, so I didn't just leave it at that. While it works, this architecture has a significant drawback in that it does not scale at all. If left in this game loop format, it will very quickly become hard to maintain, modify and expand, and there is a ton of things I want to add. There are many different code architectures for games, but I would bet that the most common one is Entity Component System, or ECS for short. And you might be surprised, but this code already has ECS architecture applied to it. It just isn't formalized, and it's exactly that formalization that allows later for easier understanding and management of the codebase. Entity Component System architecture is exactly what it says on the tin. It's about dividing the code and, by extension, the game itself, between entities, components and systems, which naturally represents different aspects and areas of the game. Entities are things. A tank, a wall, a projectile are obvious examples, but also an explosion. Those are nouns of the game, specific objects that can be pointed at. Components are properties of entities. Tanks' speed or position, walls' hardiness, projectiles' damage. Those are adjectives that describe things inside the game world. Lastly, systems control entities' activities and interactions. Those are actions that every entity can do. Tanks moves while, deflects, projectile explodes. Systems are verbs that name things that happen in the game. Going back to the moving tank, if you squint, you can kinda see the ECS lines right there. They are very blurry because you need to squint quite hard, but they are there. Variables are properties. You can add the name of the sprite to it too, since the specific look of each tank is unique property of each entity. The code in update is implementation of moving the tank, so that is a system. Same with draw. This is still very disjointed, so it's a good idea to use some of the programming language tools to keep relevant parts together. Something like structures from C or objects in microscript. Like that. Tank is an entity. Just one for now, but it does have its components right here. And here are defined systems that read and modify those components. Now having a huge array of entities becomes very easy. This array here is the whole game world. Every single thing or entity in the game is tossed into this array and it all is drawn and moves. This is the power of ECS. Make a system once and then reuse it for thousands of things in the game. Makes advanced concepts, even multi-threading, way easier to grasp too, because you can deal with it one system at a time. This is basic form of data-driven entity component system. This is exactly what Unity and Unreal are racing to implement into their engines right now. And sure, they come with a bunch of extra bells and whistles out there in AAA land, but this is the foundation. And this is also not what Panzer is using. Don't turn the video off just yet. Panzer is using ECS, just a different kind. And it's all because of this. Objects. Microscript uses objects to group properties together, and objects can not only hold data, but also functions. In objects, variables are its properties, a word that I already used in the context of components in this video. And functions are objects' capabilities, something that is handled by systems normally. The idea is to enclose properties and systems that operate on those properties into a single object and reuse those as components. For the moving tank, there would be a move component and a draw component, and both would come bundled with all data and functions needed to perform their respective purpose. Tank entity can be turned into an object too, which give an easy access to all included components. Object-oriented entity component system is a staple of game development today. Current frameworks of Unreal and Unity and many other engines are built around it, so getting familiar with the concept opens a lot of doors. It comes with many upsides of data-driven ECS I mentioned, with the power of object-oriented programming added on top. Leaving moving tank behind finally, here's how object-oriented ECS is implemented in Panzer. First of all, I created a class that will hold my game world, Game Manager. Game Manager will later keep track of game rules, but for now I just have this game world array that will hold all the entities. Speaking about entities, here's entity class. In ECS, entities themselves don't really do much, they just hold a collection of components. I also implemented few functions to help manage them, add, remove and find a particular component. This getComponent method is especially interesting because it leverages a special feature of object-oriented programming, inheritance. My component class in itself is very simple. Just a few basic properties, but components have plenty of very variable functionalities. They will handle movement, shooting, physics, drawing, sound, player input, but all those specialized components will be extending this base component class. Honestly, this isn't that crucial in the game the size of Panzer, but in bigger projects having inheritance chains of more and more specialized components can happen very often. I decided I want to build the game like this from the start to get used to the logic behind those mechanics. To make it all function, I created an instance of Game Manager and made update and draw call their respective methods from that instance. Just two more functions. One to spawn entities into the game world and the second one to destroy them, and all was ready. This framework is powering all of Panzer gameplay. From this point on, the planning changes from what I want in my game to what components I need to get what I want in my game. As an example, here are two components from before, move component and draw component, both implemented as a classes extending component class. Those are ready to be added to the entity and spawn into the game world. Moving tank, the final form. It looks the same as the previous one, doesn't it? Well, this one is quite a lot better, trust me. And that is all I wanted to say about the entity component system in Panzer. ECS can be a very complex and detailed topic, but this is more than enough for now. This video is already the longest out of all that I ever made. Out of 2 I ever made. Maybe 3 if you feel generous and include the trailer. The upside of this being just part 2 is that since I only did it once before, you won't mind that I remind you to perhaps like the video and maybe subscribe to the channel. Oh, and links for the project on MicroStudio webpage and to support the edition on itch.io are in the description, so you can check those out too. In part 3 I'll show you how players control their tanks. I'll talk about abstracting input device from the player action and how to turn input into control. I'll talk about vector math a bit too, which I'm sure is going to be very fun. This was Sebastian, and see you in the next video.